in this new section, we're going to talk about the expected value of e of x, the expected value of our continuous random variable. Well, we know for discrete, e of x is the summation of x times the probability function, the PDF. So, when it's continuous, the summation symbol becomes integral. X stays x. P of x just has a new name. It's called f of x dx. That's the formula to calculate the expected value of a continuous random variable. So, here's a nice problem. Find e of x and the variance of x if the PDF is given by this function. Is given by f of x is equal to 2x. If x is between, this is the symbol for between 0 and 1, and it's 0 otherwise. Okay. Oh, the little typo in this formula here. E of x is equal to the integral from negative infinity to infinity. Just like with the summation, we say the limits. We have to say the limits for the continuous case. Okay. So, e of x, by definition, is the integral from negative infinity to infinity of x times f of x dx. Now, whenever f of x is 0, of course, x times 0 will be 0. So whenever f of x is 0, we're just integrating 0. And that's whenever we're outside of here. Integrating 0 is a waste of time. That is, we can just integrate from 0 to 1 of x times f of x. And f of x is exactly 2x from 0 to 1. And you can pull out the 2 if you like. And x times x is x squared times dx from 0 to 1. And you get 2x to 1 more power, divide by that power from 0 to 1. When you plug in 1, it's not for x, it's almost as if x isn't there. You just get 2/3. Minus, when you plug in 0, 2 times 0 cubed is 0, divided by 3 is 0. So the expected value is simply 2/3. Okay. So let me just write that up here. Just write down two things. The expected value is 2/3, and f of x is 2x between 0 and 1 and 0 otherwise. Okay, so we have the expected value. Now we want to find the variance. Let's get rid of all of that. And the main part about finding the variance, if you're using the formula that the variance is e of x squared minus e of x all squared, the whole thing is to find e of x once you found their expected value. Because we already know that. That's our 2/3. So we need to find e of x squared. E of anything is the integral from negative infinity to infinity of the anything times the f of x dx. And or anything happens to be x squared. Again, x squared times 0 is 0, and you're 0 if you're outside of 0 to 1. F of x is 0 outside of 0 to 1. But between 0 and 1, it's not always 0. So we'll integrate from 0 to 1. X squared times f of x, which is 2x dx. You can factor out the 2, that 2. X squared times x is x cubed dx. 0 to 1. The 2, the integral of x cubed. Make the power 1 more, divide by that same power. It turns out that 2 goes into the 4 2 times. So you get x to the 4th over 2 from 0 to 1. If you work it out, you get a half. Okay, so we have e of x squared, it's a half, minus e of x is 2/3, and then you square it. So you have a half minus 2 squared or 3 squared. The common denominator between 2 and 9, the least common denominator is 18. Here, we multiply by 1 as 9 over 9, because 9 times 2 is 18. 9 times 1 happens to be 9. So you get 9 over 18, which is a half, minus, multiply top and bottom by 2, because 2 times 9 is 18, and 2 times 4 is 8. 8 over 18 is the same as 4/9. Do simple subtraction, you get 1 over 18. That's the variance. Okay, it's just e of whatever is the integral of whatever times f of x dx from negative infinity to infinity. Suppose the PDF for some random variable, again it's piecewise, it's 1, if x is between 0 and 1, and it's 0 elsewhere. Otherwise, suppose you have that, and you are asked to find e of e to the x. Okay, well, e of anything is the integral from negative infinity to infinity of the anything times f of x times dx. Well, this is only 0 when f of x is 0. And that's 0 otherwise, that is outside of here. So let's just integrate from 0 to 1. E to the x times f of x, which is 1. From 0 to 1, f of x is 1 dx. That is, e to the x times 1 is e to the x dx. The integral of e to the x is e to the x from 0 to 1. You plug 1 in, get e to the 1. Minus, you plug 0 in, get e to the 0. E to the 1 is e to the 0 is 1. Answer is e minus 1. That's the expected value of e to the x given that PDF. Given that f of x was 1 between 0 and 1, 0 elsewhere, otherwise. Okay. Try 1 or 2 more problems and we will be done with expected values and variance. Okay. Here's an excellent problem. The PDF is given by f of x is equal to all right. Now you are told that e of x is 3/5. And they want us to find A and B. A and B. Now, when I see this problem in front of me, I'm like, we find E of X, that'll only give us one equation, but there's two unknowns. So we're going to have to figure out how we could figure out another equation. Now, E of X, on one hand, it's the integral of X times f of X, which is non-zero only when f is A plus bx squared, and that's between 0 and 1. Distributing the x, get ax plus bx cubed from dx from 0 to 1. Antiderivative is ax squared over 2 plus bx to the 4th over 4 from 0 to 1, which gives us a over 2 plus b over 4, and we are told that that value is 3/5. So we have one equation here. And then you say, oh my, how do I get another equation? The answer is, if you integrate f of x from negative infinity to infinity, you'll get 1. Okay, so we have that bottom line, which is very important. A over 2 plus b over 4 is 3/5. But we need another equation. We need another equation. We had this were a multiple choice exam. We can look at the choices and hopefully only one choice would satisfy that equation. A over 2 plus b over 4 equals 5. In fact, I'm going to multiply by 20, the LCM. Multiply that by 20, I get 10a. I multiply this by 20, I get 5b. Multiply this by 20, and you get 12. Okay. The n1 is equal to the integral of f of x dx from negative infinity to infinity. But we're just going to go from 0 to 1. The integral from 0 to 1 of a plus bx squared. Okay. Dx. And this is antiderivative is ax plus bx cubed over 3. So you have to remember your calculus. You plug in 1, you just get a plus b over 3. When you plug in 0, you get 0. Well, this is 1. Clearing out denominators, and multiply everything by 3. 3 times a is 3a plus 3 times b over 3 is b. 1 times 3 is 3. So here are my two equations. And that I can solve. That's how I can find a and b. So let's get rid of a lot of stuff and solve for a and b. Two equations, two unknowns. I look at 3 and 10 and an understood 1 and 5. And it's easier to get the 1 and the 5 to be the same. I'll multiply by 5. 5 times 3a plus 5 times 1b equals 5 times 3. And the second equation I'm not going to touch. since these are exactly the same, I subtract. I conclude that 5a's is equal to 3. 5 times what equals 3? 3/5. Divide by 5, get the answer. A is 3/5. Now let's find B. I know that 3 times A, I'm reading this equation right here, plus B is equal to 3. 9/5 plus B is equal to, well, that's 15/5. You want to write 3 with a 5 on the bottom. 5 times 3 is what goes there, 15. This is 15/5. So B is going to have a 5 on the bottom. 9 over 5 plus what over 5 gives you 15 over 5. Well, 9 plus 6 is 15. That's B. B is 6/5. A is 3/5. You had to know to use the fact that the integral of the f of x dx from negative infinity to infinity equals 1. Always. Always have that fact. So if you need another equation, use it. Okay. So suppose you're asked to find e of x if the PDF, which is a random variable, is f of x is equal to c times 1 minus x squared, where x is between -1 and 1, and it's 0 otherwise. Okay. Now, to find e of x, you need to know what f of x is. But we really don't need to know exactly what f of x is. But we don't, because of this value c. So somehow, we have to find out what c is. I guess you can find the expected value first. It'll be in terms of c. And then you can do what we're about to do to find c. And then go back and update your expected value formula. But for some reason, I'd rather find c first. We know that 1, just like before, is the integral from negative infinity to infinity of f of x dx. But our f of x is non-zero between -1 and 1. And f of x is c times 1 minus x squared dx when x is between -1 and 1. The c I can pull out in front. There it is. The integral will be the integral of 1 dx is x minus the integral of x squared is x cubed over 3. And this goes from -1 to 1. When you plug in 1, you get 1 minus a third. Minus. When you plug in -1, you get -1 plus a third. If I change this to addition, I have to change both signs inside. 1 minus a third plus 1 minus a third. Well, that's 2 times whatever 1 minus a third is. 1 minus a third happens to be 2/3. So I get c times 4/3. And if this is to equal good old 1, c must be the reciprocal of 4/3. c is 3/4. Okay, so I come back to my f of x, which is on the second line, and I replace c with 3/4. And now I can find e of x. That was the question. Please find e of x. Look at the very top line. Find e of x. You can't find e of x unless you know f of x. Just the way it is. E of x, by definition, is an integral of x times f of x dx from negative infinity to infinity. But outside negative 1, 1, it's 0. It being f of x. And x times 0 is 0. The integral of 0 dx, I don't care what limits you have, is 0. The reason is, what's the antiderivative of 0? What do you take the derivative of? What do you take the derivative of to get 0? A constant. I was thinking it was 0, but it's a constant. And when you go from one limit to the next, when you plug this in, whatever it is, 3, 13, you get c. Minus, is that 7 or 77? When you plug 7 in for x, c is c. You get 0. Again, it's the area under the curve. There is no area between the x-axis and the curve. There's no area. Alright, so in any case, we're integrating from negative 1 to 1, x times f of x, and in our case, that's f of x. I'll bring the factor 3/4 in front of the integral sign. So I have 3/4 times the integral of negative 1 to 1 of x minus, says minus, x cubed times dx. Not just x cubed dx. The whole thing is times dx. And we get 3/4. Integral of x is x squared over 2. Minus integral of x cubed is x to the 4 over 4. From negative 1 to 1. Now if you're slick, you can notice that this is an even function. Whether you plug in 1 or negative 1, you get the same value. You're going to get the same value. And when you subtract them, you're going to get 0. 3/4 times. You plug 1 in, you get a half minus a quarter. Minus. When you plug negative 1 in for the x's, you get a half minus a quarter. Whether you know what a half minus a quarter is, you should at least know it's a number. And this is the same number. And when you subtract the same numbers, you get 0. And 3/4 times 0 is 0. The expected value is actually 0. And this completes the section on expected values and I guess variance of a continuous random variable.